Hello, and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 97,000 computing professionals and students who are ACM's members. I'm Jan Timonovsky, ACM Education and Professional Development Manager. For those of you who may be unfamiliar with ACM or what it has to offer, here's some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen right now. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including communications of the ACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database of computing literature, international conferences that draw leading experts on a broad spectrum of computing topics, and support for education and research, including curriculum development, teacher training, and the ACM Turing and ACM Prize in Computing Awards. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. You can download the deck from the resources window on your screen. You'll see it on the right. On the bottom panel, you'll find a number of additional widgets and resources. If you're experiencing any problems with slides or audio, press the F5 key in Windows, Command plus R if you're on a Mac, or refresh your browser on a mobile device. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during the webinar, please type them into the Q&A box at any time during the talk and click the Submit button. I'll organize the questions as Robin speaks, and she'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And check learning.acm.org and webinar.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the link to the survey at any time from the resources window on your screen. You can also use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweets and questions using the hashtag ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after the webcast, including questions we won't be able to get through during the Q&A session. Today's presentation is Computing and Disasters by Robin Murphy. Robin Murphy is the Raytheon Professor of Computer Science and Engineering at Texas A&M University and Director of the Humanitarian Robotics and Artificial Intelligence Laboratory, and member of the Center for Robot-Assisted Search and Rescue. She helped found the fields of disaster robotics and human-robot interaction, concentrating on developing human-centered AI for ground, air, and marine robots. Her work is captured in over 150 publications, including Introduction to AI Robotics and the award-winning Disaster Robotics, as well as a TED Talk. Murphy has developed robots to over 27 disasters in 5 countries, including the 9/11 World Trade Center, Hurricane Katrina, Fukushima, and Hurricane Harvey, most recently. Her research also includes preparedness and prevention of disasters. Murphy's contributions to computing have been recognized with the ACM Eugene L. Lawler Award for Humanitarian Contributions. Robin, without further ado, take it away.
Well, thank you. And as we say here in Texas, howdy. And we've gone through a little bit about me, so let's just move into one of the reasons that you're probably attending this webinar is Hurricane Harvey. What an amazing event. We're talking just $125 billion in federal relief to Texas. Not of the other states, just to Texas alone. And that's not counting the loss of houses, what the loss of the tax base or revenues to those communities are, all of the lost productivity. There was like 20% of the oil refinery in the Gulf Coast was impacted by it. $125 billion just right up top. So there's a lot of opportunity for us to help both economic recovery and, of course, life-saving, which is what we'll go into. But first, let's just look about Harvey, and let's go to this particular video, if you don't mind bringing it up, that Fort Bend County prepared for us. Tell me when it's finished playing. No, it won't play. All right, so you should be seeing that YouTube clip from Fort Bend County. And as you look over, I know I'm talking over the voice of it, but as you look through, think about all the devastation, all the things that there might be possibilities for computing. But mostly think about the impact. And so I believe most of you are probably done playing it, or it's going to be just hopelessly there. So let's go to one of the points here is that Harvey was one, right? Was just one event. And we think of that happening 1 or 2 times every 4 years. No, actually there's an average of 60 major federal disasters, most often flooding related, and they cost, without one of the big ones like Harvey, an average of $7 billion a year. So really they're expensive, as well as threatening lives, as we saw at Harvey and Irma. Now, the main points of this tutorial kind of talk is really everything I wish I had known 20 years ago when I got into research for disasters. So I want to go over the types and phases of a disaster. I would like to just briefly kind of explain why emergency management is a lot like academia. And then I'm going to go through and try to walk through some stories to illustrate the challenges in informatics, networks, social media, data, and visualization, and just a short summary of research needs. So let's return back to Fort Bend County. I'm going to do a little pop quiz here. And I do disaster robots, so I always tend to think of things as robots, but then the informatics as well. So at Fort Bend County, the group I was with, they did a record 111 UAV flights, starting 2 days before it hit Houston, so pre-mapping out, flood inundation maps, things like that. They were able to fulfill every legitimate request that came up through what I'll show you is the Unified Incident Command System, all of that. Fort Bend County, by the way, is the large suburban county west of Houston. So, quick question. How many people on roofs did the UAVs rescue? None, because they weren't used to rescue people. The UAVs were being used by Fort Bend County, who knew where people were trapped because they had cell phones and the cell phone structure was still intact. They were helping the responders find the shortest way, the best place where to put in their boats to go get them. They were using the UAVs to see if the flood inundation maps were holding true. If there were some problems, they were looking to do overall damage assessment. Fort Bend was very fortunate because they had very accurate maps of where the damage was. They were able to get all the dump trucks that you need to haul away waste when you're trying to do the cleanup after the water recedes. A funny part of emergency management is that kind of you snooze, you lose. Think about that's a tough resource to get for cleanup, but cleanup's really important. Rumor control, one of the things they used UAVs for every morning and every evening, the county judge, who was for a county in Texas, is like the CEO, the executive officer for the county, the top person, he would look at social media. He would see people say, oh, somebody said our house isn't flooded. Why can't we go back there? Why do you have this evacuation order? And then we'd get one of the tasks would be to go fly that neighborhood. And then that evening he would show that, yes, technically your house is not flooded, but notice that there's like, it's so flooded up to the doors of your house. There, you can just see the rooftops of the cars from the water, the dead deer, and see that big orange spot? That's actually the sewage, raw sewage in the water. So that's why we're not letting you back in. It's a health hazard. And then, of course, bridge and levee inspection. So technology has so many positive uses. A challenge is that no two disasters are alike. You know, a week later we had Hurricane Irma come through. From the UAV perspective, totally different. Where in Harvey, we're looking at damage assessment, flood inundation, all of those things, and looking at videos and still images as your primary data product. At Irma, it was all wind damage. There wasn't a lot of flooding. So instead, the flights and the information they wanted was the classic FEMA property damage assessment. All of these critical infrastructure points, like lift stations that you need for sewage treating, all that, go out and check and see if they're intact and get us 5 pictures, you know, each side, and try to get a top-down view. So quite different. So any solution you come up with, usually it's kind of generalizable, but maybe not. And so I think that has always been a problem for us as computer scientists, is that we tend to come up with a solution that works perfectly for the last one and then get surprised when no one's interested for the next one because it doesn't fit. So let's see if I can get some generalization for you to help you see the general trends and to inform your future research. So what's the difference between a disaster and incident? So formally, an incident is a routine emergency. I know routine emergency is an oxymoron, but it's expected. You know how many times the ambulance is going to have to go. You know that. You know fires will happen, so you prepare for those. A disaster is an incident that exceeds local resources. So now you're reaching out. If you're a city, you have to ask the county, you have to ask the state, or even the federal government or agencies that you normally don't call in for an incident. So that's a formal definition. Now, you'll hear something called all hazards. So all hazards approach is that what do every single disaster you can think of have in common? And so a functional decomposition of all hazards is really by the kind of look and feel. There's stuff that's kind of in urban stuff that we're talking about a small area, our buildings, our built structures, which is something like the World Trade Center, or parking garage collapse in New Jersey, or something like that. Then you get a wide area. That's where lots of stuff is going on. Your hurricanes, your earthquakes, your tsunamis. You've got multiple geographical areas, multiple things going on. And then you have medical disasters, things like the Ebola outbreak that come in, or a cholera, something that's very, very important. We normally put medical in a special category. They have their own actual formal response plans. And an interesting thing about that is that medical people are embedded into the all hazards of regular urban and wide area types of disasters because they're trained to deal at the point of injury with casualties. So they're like EMTs and paramedics who are also responders who are there to take care of you until they can get you to the formal medical response with the ambulances and then a hospital who can do point of care for you. Right? But that doesn't always hold. Let's talk about Ebola. And of course, we had an Ebola outbreak in Dallas. And guess we wound up with the fire department in the middle of it. And that was because, well, you've got lots of possibilities or problems with this. First off, the person who had Ebola was allowed to enter the USA. He was misdiagnosed by the hospital in his first visit to the emergency room. And then once they did it, the hospital personnel overreacted and sort of decontaminated and just about shut down the hospital, which is really bad for everybody else in intensive care because anytime you move people, it's a problem. But the fire department, the Dallas Fire Department, took over everything outside the hospital. They had two ambulances before it was over with had been contaminated. And they know how to do hazmat. They took over what are we doing with the guy's apartment and his family? And they stepped in. So this idea that medical is different than all hazards, it's kind of true and kind of not. But it also adds why designing for disasters or trying to create some perfect dashboard often doesn't work. So that's it. Let's go get into the phases of disasters and the types of activities that are happening at that time. All right. They're social scientists who study disasters and stuff. They fight over these types of diagrams. So if you're one of those, yes, I know. But this is a simple one to understand as a cycle of prevention and preparedness, response and recovery. They also fight over the names of how you can further break those down. I'm just taking one and going with it. But for our purposes, let's think stuff you do before, usually you don't do, before the disaster, the incident, and then stuff you do after. Now, and then we're going to talk about that. All right, and then we've got something called humanitarian relief. And just technically from emergency management, public safety consideration, humanitarian relief generally refers to things that people are doing to reduce individual suffering, whereas the formal response, being government, is committed to making decisions for the greater good, like fixing roads and bridges and sewage treating plants and things like that, versus making sure everybody's got enough clothing. All right, let's go look at these in more detail. So let's look after the event happens, the post-disaster, the post-incident event, and not every disasters like a flood will keep going for a couple of weeks as the surge continues. Anyway, let's take the initial response. So somewhere a very short period, hopefully a short period of time, is the initial response. And that's when everyone is focused on life-saving activities. And there is an incident commander, whoever has incident command authority, they can enter property, they can chase people out, you can go anywhere you want to, but if you abuse that, there's a public accountability that'll be taken away from you. After 52 hours, there's a low probability of long-term survivors. So if you happen to be alive, huge mortality curve at 24 hours and then at 52, if they get you out of the rubble or they rescue you and you're barely alive, you'll probably die in the hospital. So we really want things, the big push is for that 52 hours statistically. And then FEMA, interesting, they understand this. That's why they limit their teams to 10 days deployments. They said if you haven't got it resolved in 10 days, we're in a different game, and we're going to have to bring in even more people and start rotating our professional responders out, because otherwise they're going to burn out and tire out, and it's a very intense thing. All right, so that's the initial response. Life-saving, incident command, probably evacuations, but the formal responders, it's all about them trying to get in there. The restoration phase, little broader, because it's still the incident command, but we're trying to mitigate and restore basic services. So once we've gotten the life-saving part over, now let's worry about what it takes to get those power and utility teams in there safely, because if anything goes wrong, you don't have enough resources. There's no ambulances to go get them. There's no roads to get at it. So you want to make sure everything's safe for them. You start bringing those mitigation and restoration. What is the state of the sewage systems? All of that. And then that's starting to go back to the local agencies, like a city or a county, to figure that out. Okay, and then, but the citizens are not allowed back in, particularly if it's a hurricane. You're trying to keep them out because you don't have basic services, of which fire, law enforcement, and rescue is part. By definition, that's not focused. It's still focused on the life-saving restoration. They can't handle any extra capacity of just regular day-to-day stuff. So it's still at that point where you're not back in, or they're trying to keep people out. Then we hit the Reconstruction period. And as soon as we declare the disaster is in Reconstruction, now the incident command, now you just can't go stomping around somebody's property to launch a UAV or do this or check out, because it's now, that part's over. So the Reconstruction phase is looking at now we've done patches on the sewage system. We've done this and this. Now we got to go back and really do it right and make sure people get back to their houses and schools are reopened and that. And what you see, the first two phases are really focused on engineering and infrastructure types of decisions. And now we're going to start moving toward health and human services. The insurance companies are coming in. All of those types of things start in there. And then later on, you get to the betterment phase, the recovery phase, where you're reconstructing, you're trying to do better, you're trying to mitigate some of the, or not redo, make the same mistakes that led to that particular type of flooding and all of that, and that can take years. So Hurricane Katrina is still got parts, the last time I looked, like 2 months ago, it's still got parts that are still being funded under FEMA Recovery Act. So it can take a big one, 30 years for a community to recover. How do you know when you're at the end of a phase? Well, in theory, somebody with instant command would say, it's over. You know, this is over. We are ceasing all life-saving operations, responding. There's some magic phrases. Politically, they don't always do that because what if there's hope to find one more person? All that. Okay, so what you really do is kind of look between the scenes. Did the search and rescue team stand down? If they're gone, then at that point you know there is no initial response focused on life-saving or victim recovery. Restoration. You're not really restored if you don't have the schools open. Right? Now, if it's during the summer, that, you know, fair enough. But the idea is that means if the schools aren't opening, you may be back into your house without access to sanitation, but you're not opening a school if you don't have clean water and sewage. Okay, so that's, and electricity. So all of those things, that's the biggest indicator that there. And also, you're not getting your economy, your workers back to work if their kids can't be back in school. Where else are they going to go? Then in reconstruction is when you have the houses repaired to occupancy versus, you know, family members back there trying to make sure nothing gets looted or starting to tear out the sheetrock or trying to meet with the insurance people. And then the betterment ends when there's no economic recovery or no federal aid when that's complete. So I really like to focus on the first two phases when it's formal stakeholders, where the initial response and restoration, where you have that engineering and infrastructure decisions are being made that really requires expertise. And that, by definition, expertise is rare. And so we, as computer scientists, should be adding and helping them use computers to help supplement expertise and also to help this lack of, or this a rare commodity and help amplify and extend it. So let's talk about who the stakeholders are. And there's a national response framework that was passed in something called the Stafford Act. So you'll hear those terms bandied about, oh, well, the Stafford Act. Okay, it's this document, right? So in the national response framework, they give specific roles or authorities with accountability. They list who the formal stakeholders are. They also recognize that there are informal stakeholders, but they don't count. They're the people that come in, or they're the groups that come in after that initial response and restoration. Now, NGOs fall into that category with the exception of the Red Cross. The American Red Cross has a specific role in as a formal responder. And then you have citizens again. Citizens have a voice, but not during that critical initial phase that's so heavily focused on expertise. So who are those stakeholders? Well, there's 15 groups, 15 Federal Emergency Support Functions, ESFs. And they're all supposed to work together magically through this thing called Unified Incident Command, which does kind of work. But in general, when you have a disaster, you've got the law enforcement, 13 public safety and security people are off doing law enforcement things. You've got the firefighters going off and doing firefighting sort of things. You've got the transportation people. They don't need anybody to tell them. They've got to figure out the state of the roads and the bridges. So they can all work a little bit independently without a huge amount of coordination. But what's interesting, formal stakeholders are not always knowledgeable that there are formal stakeholders. So Hurricane Andrew, which was kind of like Harvey for us here, back in the day, the Florida governor's office forgot to officially request the National Guard to come in and help. And Katrina, we all know, the governor's office forgot to request FEMA. And this is a principle of emergency response all over the world is that it's local, it fails upward. If I can't do it, then I'm going to call the next higher one, which is if I'm a small town, I'm going to call my county. If the county can't handle it, then they're going to bop it up to the state. If the state can't handle it, it's the federal. The feds do not come in. It's a very big deal. The feds do not come in and run anything unless explicitly asked. And in local authority, think about that here in Texas. The county judges declare the emergency. They declare evacuation. In Florida, it's the sheriff's department. How many of you think are really that knowledgeable about big events and some of the nuances there? And at the ozone mudslides, we watch the county actually override incident command. So the stakeholders can be kind of an interesting mix. But in general, the earlier in the phases, we're focused on public good, using specialized expertise, are very high public accountability. Elected officials are city managers who are accountable to the people and very aware of that. And then we start moving toward things where there's public policy set by citizens as individuals and volunteer organizations and things kick in. Now, that said, how do you get involved with this sort of thing? So that's where I want you to think of emergency management as academia. So if you're an academic, I think you'll know what I mean. So in emergency management, you probably thought there was a nice top-down hierarchy, like the FEMA was in charge and this was in charge. No, no, no. It's a lot like academia. You know, it's like you can have a dean or a college president, provost. It's not really enforceable. They can do things, but, you know, not so much tell you what to do on a day-to-day basis. Also, there's a lot of emergency support functions like departments, and each one's different. So, you know, as computer scientists, what we really love to hear, at every university I've been to, they're like, oh, all the computing needs should be handled by a central authority. And we're like, no, computer scientists are a little different. Okay, a lot different on what we need out of computers versus the English department. You got to do that. Okay, well, you're just like mechanical engineering. No, actually not so much. Closer, but not so much. So one size fits all won't work. And the same thing if we look at trying to come up with solutions to help these groups. The culture in the organization varies from state to state. Louisiana, Texas, New York, California, wildly different in their policies and state organizations. Also, one of the things I know, two things that happen a lot in academics now is that we get, you know, boards of regents with industry. Oh, well, we need to run in academia, more like a business. Or we get that, oh, you know, which is probably not true. And then outsiders think that, well, look, I talked to this instructor at this local community college, and they said this and this, you know, machine learning will be used by 20% of all applications in the next 2 years. It's like, well, that's not exactly the same as a Turing Award winner. So your local fire department, your fire chief may be knowledgeable, but he may not be a thought leader or really one of the experts in the world on stuff like that. So you have to just be aware of that. But mostly it's not a top-down hierarchy. So any hierarchical solutions don't work for us. All right, deep breath. Whew. Background. Now we're going to get into more of the computer science stuff. Let's start off by looking at the informatics. And we're going to, again, focus on what's happening in those phases. And so the question would be, what are all these people doing? What kind of decisions, what kind of data, what kind of information do they need during those first few critical days? Because that's when people, you're going to save their lives or you're going to have huge consequences, positive consequences on the economy. Well, here's the timeline that developed that is sort of a summary of everything we've seen. So the first hour is the golden hour. If you can get to people who are injured within the first hour, you know, medically that's the great thing. Unfortunately, once you go to a disaster where you need like a formal search and rescue team, or you need to do an evacuation, the law enforcement to do certain things, or that, you're talking about 4 hours from either that city or that regional county group to arrive. So you're already 4 hours down on the count after something big happens. And that's a big thing why you try to second guess, like with a hurricane, at least you kind of know where to pre-stage. Earthquakes, you're kind of stuck. All of these groups are working independently, doing stuff. They don't have a lot to say to each other because what is there to say? The law enforcement is try to keep people from coming in that shouldn't be into the area. Fire rescue is trying to save people. There's not a lot of coordination that's needed for that. You might get your first real incident command coordination mission between all the ESFs around the 12-hour mark, certainly by the 24-hour mark. Okay, if we look back at that 52, 53 hours where the mortality health curve inflection occurs, and then at about 72 hours is when people who are in the disaster, the victims, their resources are generally exhausted. FEMA's always saying, states are always saying, please have 72 hours, be good for 3 days. And so you really want to make sure government has an implicit contract to get to people within 3 days, the 72-hour mark. So that's kind of the timeline. Great. Well, here's a chart that Leo Lachat, who was head of Florida State Emergency Office of Emergency Management, I put together. And if you look at the impact of information, no surprise, the impact of you being able to do your job as a responder goes, the more you had at the beginning is really helpful. And as time goes on, you don't need it. You've already made all the decisions, or you've already committed resources. Like in one case, Hurricane Dennis, we were all pre-staged down in Pensacola. It looked like it was going to do the exact same path as Hurricane Ivan. It did not. And as soon as we found out that the damage was much less, even though everybody was pre-staged, when Florida Task Force 3 realized that wasn't it, it had actually hit worse due to storm surge east of there, all the resources were already committed to a different location. So they had the information too late to be able to make much difference. Fortunately, it's a very rural area, didn't really do that much damage. So the availability, unfortunately, is the exact opposite. You don't have information. You're just kind of running blind off of what you're seeing. So now we have this idea, informatics. Wouldn't it be great if everybody had wireless networks and they could talk with each other and see what every other group is seeing all the time? And so that raises the question of who would be talking to each other and what information do they need? Now, let's go back, and the wrong answer is to say everybody needs everything all the time. No, people can't mentally process everything all the time. They can't figure out how to look through it. So let's go back and let's try it this way. So let's think about the spatial distribution of a disaster. We're going to use kind of classic science fiction scary terms, epidemiology terms like hot zone, warm zone, and cold zone. So the hot zone is where the disaster is, okay? Where you'll have an evacuation, things like that. And people there are looking, they're the boots on the ground responders. And at most, they've got a nice SUV, maybe with a satellite internet there. The cold zone is where everybody in the nice air-conditioned offices with bathrooms is at. That's your state emergency operations centers, your joint regional operations centers, all of these things where lots of people looking important, and the governor comes and looks sad in front of a lot of people and big displays. The warm zone is where you see all of those mobile RV trailer command centers, and so it's really the buffer zone. It's the warm zone is at the edge of the hot zone and doing that, and they can all be connected. So a fun thing about this is that when you look at it, is that when you look at disaster response, and it hasn't changed from 2015, is that if you have a disaster, remember you've moved from an incident to a disaster, as soon as you hit that local, you need outside resources, you will probably have about 25 different agencies. There's emergency support functions, but there may be multiple agencies within you, the EPA, things like that involved in the disasters. And what happens if you have a flood that goes across 4 counties? Oops, now you've got all of the counties handling their local with what are we doing to coordinate between the 4 of them versus all of that. Okay, so just keep that in mind. Now let's look at what people want. Let's get back to that. So if you are a strategic planner, that's one of those people in the cold zone. And the nice offices, they're working frantically to try to support the people who boots on the ground. What do you want? there's a document called the Essential Elements of Information. And it's basically the strategic planners want everything as little pins on a map. They want to know the disaster area. They want to know what the jurisdictional boundaries are, because that controls a lot, you can imagine. They want to know hazards. They want to know, this, we've got an oil spill over there. They want to know weather conditions. They want to know, wait a minute, we've got we don't have gas like in San Antonio. Wait a minute, all the pipelines and all the transport systems are down, so nobody's going to have gas or diesel for their cars in San Antonio. Things like that, and they want it on a map. Fair enough. Be aware that everybody else, and in a certain degree, everybody who is in the hot zone or warm zone who's doing the real work, wants something else. And what they want are things like video, images, photogrammetrics. They want to understand. Seeing is believing. They need that to use that human perception to quickly assess of what's going on. So at the ozone mudslides, ESF3, Public Works, is trying to prevent more flooding, more mudslides. It's taking 4 to 6 days to get digital elevation maps from the USGS because they're using satellites. You couldn't use manned helicopters to get back in some of those areas. UAVs were able to do it in a much faster time, less than 2 days, in 1 day. Meantime, at the same time, ESF9, Search and Rescue, sitting right next to them in the strategic Emergency Operations Center. But in the field, ESF9 wanted real-time situation awareness. Who's out there? Anybody there? What are we seeing? It turns out the same UAV could provide information to more than one ESF, but radically different in what they wanted, even though they wanted it at the same time. So keep that in mind. Now, let me just throw in again on this informatics and computing problem here, and we'll continue to come back to it. It's that UAV at the ozone mudslides covered about 40 acres with created digital resolution maps of 4 centimeters. Wonderful elevation maps, great, in about 3 hours, but it was about a 1 gigabyte file for some of that. And there's no wireless communications. And then when you think about it, really, what cell network do we have that's going to do a 1 gigabyte file transfer? So in most cases, you'll find in disasters, emergency responders just get used to having a courier to take a thumb drive back and run it back, which leads to lots of opportunities for edge computing, high-performance computing, screening in the field. But we'll get to that in a minute. But in the meantime, since the ozone mudslides, UAVs have gotten smaller, cheaper, and better cameras. So now they're doing the 4K resolution cameras. You can't real-time stream that even, right? So even on a good day, you have to drop your resolution to do the streaming through YouTube. And then you've got a single 20-minute flight that if you take images like you're doing a missing person search, you'll get 800 images that are close to 2 gigabytes. What are you going to do with 800 images and 2 gigabytes? What network are you going to do with that over? So let's talk a little bit more about networks and wireless. You actually do have networks after a disaster, at least in the United States. Certainly Maria's of that. What they found is that the telecommunications companies will bring in the cows, the cell towers on wheels. They're pretty good about pre-staging. And even if regular people don't have access to them, civilians, they're pretty good, and they try to prioritize getting it to the emergency responders. And there's a new program from the Department of Commerce creating a whole LTE network just for first responders called FirstNet. But in the meantime, another trick of the trade, as soon as the weather clears up, you put repeaters on the Civil Air Patrol, little Cessnas, and then now all the responders in that hot zone can connect to the Wi-Fi through there. You, as a civilian, won't see it, but that's okay. But in the hot zones, the bandwidth still exceeds capacity, even with all of that. So once again, we're talking about these kind of UAVs, these little small things you can buy off of Amazon, 4K cameras, wonderfully realistic. And then now what do you do with it? So here's from the Louisiana floods where one of the American Red Cross people, he only needs 90 seconds in it to show the incident command what he needs to show them about the definition. We're about a 3-hour drive away. He doesn't want to stop what he's doing and run back to that. But we've got cell towers up, so he actually takes his cell phone, takes the image, plays it on the laptop because it's too hard to cut and paste and edit on a laptop, and he just plays it on his cell phone, and then he can hit one button, send, to the mailing list. He doesn't have to re-implement a mailing list and say who needs what and that. And so people are solving our bandwidth and our distribution issues now, and I think that's a really interesting problem for us as computer scientists to do this. Another one associated with it is that, oh great, how did he know it would get there? How did they know they actually got real thing? They're not being spoofed. So we've got to think about how we're going to handle the demand cycle, because right off the bat, lots of people are going to be dumping lots of information. At Harvey, we had 6 teams in the field at one time. So all of them dumping stuff. Visibility of what is the state of the network. We never know, is it me or is it them? Is it a Wi-Fi problem because and so I have been on numerous things in the warm zone where they come in and yell at everybody, and I do mean yell, say turn off every Wi-Fi device or we'll pull the plug or kick you out. And then everybody boot up until we find who's hogging all the bandwidth. That is not a wonderfully productive thing. Okay, autonomous selection of alternatives. What are my options? Well, even better if I don't have to think about it, because if I'm a responder, I'm busy. And if I'm a responder, I probably haven't had much sleep over those 52 hours. And I never get sleep going into it. You never rest up. You're always preparing, unless it's an earthquake. And then that's just luck of the draw. We need context-sensitive prioritization and routing. There's some things you need to see in real time. Some things could go over to them, and if they get it, like I said, in 2 days, they think they're ahead of the game. They can't really, their system isn't even set up to get it really fast. So how do you prioritize that and route that? Fortunately, FirstNet's got some hooks into it, but no one's come up with the algorithms yet to do that. Cybersecurity. Credentialing is a big problem. Now, you need to be able to have new people that are in the organizations come in and get in. So who's working? Oh, we forgot to update that we've hired these 2 people, or they've changed departments. And then that right. Like us, when we deploy, and we deploy at the request of an agency, they want to include our people, but how do we get our names into their roster without taking somebody who's just dedicated to checking out everything, which is what happens, which again puts manpower that should be used someplace else as doing paperwork. And then a big issue, provenance of data, which is sort of related to that cybersecurity. Is this data really the data of this flood, or is it of a flood, or is somebody trying to hide something, or is something going on here? And if we're saying that that is an oil spill, or it's a chemical spill from some evil corporation that we want to sue, how do we know that's true legally? There's a lot of accountability. Oh, and then we'll also get into what if there's personally identifiable information in it. That's kind of uncool not to know the provenance and to keep it secure. Posting it to the open is really a problem. All right, and so just to give you an idea, this was on one of the minor major floods in Fort Bend County, how many people it took to do all of that. Okay, you wind up adding a lot of people. And so I'd like to look at this, think of this, particularly for you in high performance computing. If you could build me a high performance computer where everything fit in a TravelPro roller board, I can't put it, I can build you one that fits in the back of an SUV. I remember I've got to put all the robots, or I've got to put my personal protection gear, or I've got to put the responders in the truck. So give me that's a good footprint to look at. And it can run off of a car battery, then we're great. Anything else, not so much, won't be used. So we really need to have edge computing, because we have fog computing because of the bandwidth issue. If we have a network, we don't have the bandwidth we need. So we really need the edges themselves to be doing more of the computation. Right, which leads into, and if we have the internet, then we can exploit crowdsourcing and social media, which leads many emergency managers to wish they had never heard of the internet. So, Fort Bend, like I said, the county judge had to constantly devote resources to but for good end, right? You know, you're getting information to people, but to combat rumors and concerns, all that was being posted to social media before it became viral, and this whole thing about how badly the disaster was being run and we should be able to go back and screw them, go back to your homes and stuff. They had to do that, okay? And they saw a similar problem in 2015 when somebody had posted, oh, everybody from this neighborhood needs to evacuate, the levee's breaking. Well, the levee wasn't breaking. It was actually an agricultural levee that might have gotten some way over with a bunch of cows. Okay, cows are important, particularly in Texas. You know, you can have $1 million per cow. But anyway, they couldn't. The problem was now they had to stop, delegate a person to find who made the posting. It was a private post. They couldn't find out who, and get them to retract that, and then try to promote to everybody else saying, no, no, your neighborhood is fine. You know, and get that down. So it's adding that, which is why I love stuff like from University of Maryland, big shout out on Newsstand and Twitter Stand, which is trying to come up with these, okay, people are talking about stuff and they're not using them. We can never predict what their hashtags are. We know that. But what is it so that we can figure out what's going on? Again, we get back to credentialing. This is a big deal. You know, are the people showing up to disaster who they say they are? If they show up, are they up to date on their certification? So there are legal ramifications for being at a disaster. If you were the agency with incident command and your people aren't, they're doing search and rescue, ESF9, and their certifications are not up to date and something screws up, they are liable. So they want to see that. And if there's any doubt, the answer is no, and you accidentally lose, possibly accidentally or unintentionally lose important responders, so an important resource that you don't have because it's impossible to keep up the certification database in there. And then if they come in with it in paper, how are you getting them all in? And okay. And so Andy Van Dam, right after 9/11, he and I sat down and said, you know, looking at the 9/11 response, that was one of the biggest problems was although they had a lot of responders, but they couldn't credential them and they had to say, no, you can't participate. We see this a lot. We saw this big problem at Hurricane Harvey was what has been referred to. It happens at other disasters. We call it disaster tourism. Very well-intentioned, untrained, out-of-state teams came in, called in by the American Red Cross, local Red Cross, and I say, oh yeah, sure, we'll fly for you. We can do, we'll do the disaster mapping for you, all of that. You know, absolutely coming into areas where it was evacuated, so you're evacuating that, and violating both FAA regulations and on top of it, violating Texas rules. Texas has different privacy and UAV rules than other states, so not well-intentioned with that. And then, meanwhile, anybody during this first initial response and recovery, all of that is handled by the response professionals. They have a system of making requests. So all of the requests were actually getting filled for Fort Bend County, and I'm pretty sure in Harris County. What we were hearing is like, well, they're not getting requests. Their people are making requests, and it's important. It's like, you know what? The emergency management system has decided decades ago that a doctor's office is not a priority until the Reconstruction phase. So we ignore those requests. They are not a formal request. There are things people would love to know to get the insurance started on their houses. And counties are now working with that with the insurance companies to share that information and get that. That's fine. But it's not a formal request. That has to wait. You've got to get that, let them get in there. So that's a problem. All right, another problem with social media and crowdsourcing is you can't crowdsource if there's no crowd. So in 2015 floods, ESFA, the medical people, the ambulances, they usually use Waze because, you know, Houston traffic is horrible. And all of the hospitals are located in a bowl, by the way. It's like in the lowest elevation of Houston. It's like if you could just dig a hole and put your hospital there, great. Well, wonderful. That's how they get around. Guess what? They can't tell which roads are flooded out on Waze because nobody was out on the roads. Crowdsourcing doesn't work if there's no crowds to do that. So you've just got 10 or 12 ambulances that are trying to old school figure out what's the way to go. All right, let's move on and talk about data. Here's a story. Let me tell you a story about the 2015 floods that hit Texas and Oklahoma. Huge loss of life over the Memorial Day. People who were camping out in some of the most beautiful remote campsites in the hill country in Texas. About 40 people were killed. 21 missing persons were not found immediately. Probably washed down river over a 5-mile area, impossible to get to. What a great thing. Well, volunteer NGOs came in with canines, and then you have lots of uncertified dogs that were giving false positive. They were finding, a dead possum or deer, and then the responders are coming to that location saying, yep, it's a dead deer. That's a little different than person, which gets back to that credentialing. How did you know which ones are the certified dogs versus the ones that are kind of in training? And here we've got a little bit of video that should be playing just to show the view from a UAV. That was a major event in terms of UAVs. There were about 20 different groups brought in their own device to try to find those missing persons. Okay, and it was just a amazing event because the imagery was untagged geospatially. So if they had found anyone, sure, supposed to be looking at that. If they had found anybody, yeah, okay, great. No one would have known the GPS coordinates, and then trying to go through 5 miles of wilderness, how would they know? It's, and we'll fly a UAV over it, great. It's like find it again is very hard. So there were all sorts of problems with that. So, and you're not going to see a lot as well from that kind of low resolution video. Okay. What you want to do is get geotagged imagery, high resolution imagery, and then typically you have a person, usually 3 people look at it. But think about that, 80,000 images, a person's going to take maybe 10 seconds to look at that high resolution to see if they see any flash of color, any angles, anything that indicates debris. Our person might be there because if there's debris, there's a big one, that's probably where maybe a victim will be there, that's great. 22 hours. A person is probably a reasonable estimate to go through, basically a few flights. Okay, and you want to have 3 people. So some of the groups said, look, we've just taken this, we can't tell, so we're going to post it to the web and everybody come in and look at it. And it's like, you've just violated, you cannot, what's wrong with this picture? We're going to put up 800 images and say, try to find the dead bodies in this picture. You have violated every privacy and ethical thing. And also, you're not particularly sure if these people are trained at looking at aerial imagery. So it's like, quick, you must take that down. So these are the things that poor emergency managers have to deal with and why they kind of cringe when they hear the word crowdsourcing. But you can do what our tribe as computer scientists, what we are good at and should be doing more of is things like this. Some of my students whipped this up over that weekend of the 2015 Memorial Day weekend. Running anomaly detectors. One thing's not like the others. What is different? Machine learning on what's about these images and different, and then doing that. The same thing with urban debris. Straight lines. Orthogonal angles, non-accidental properties. We know that back from David Lowe's fundamental work in computer vision. What I love that. And so what they were able to do, and you could do 22 hours manually or 90 minutes on a laptop. Didn't get everything perfectly, but at least it highlighted where to look, and then it had a bunch of images that we can't tell if there's anything here or not. University of Maryland, taking some wonderful work from Berkeley with a cafe from there to look at machine learning. They get a problem of, and I love Trevor Darrell's assessment. He said, yeah, these are the types of images over there in the lower right is when you say, overhead imagery for floods to train. It's not like internet, it's not like cats where there's lots and lots of images on the internet to learn from. You've got to be able to learn from very, very few examples because every disaster is different. So in this case, they said, hey, these are the things that we would probably look at that's big enough for a person to be tangled up in. Can you make sure we know where they are in the image? And then on the ground, we'll go to that GPS location and check off that we looked at it. And so only being able to do that with 10 or 12 or 100 images versus thousands and thousands of images, that becomes really, really important. And big shout out to see how to do that. And then common ground is so important. Right now, you're putting everything on a map and you're doing lots of overlays. And they said, please, no more layers. We can't see which layer is relevant to me, and it's this and that. And so lots of problems in data mining and visualization. Ontologies. How do you know what's in that pen? How do you do things over time? What's the symbology? The data sources are heterogeneous. Sometimes it's a person calling in something. So it's a log file, a human parsed text file versus imagery. How do we do that? And can we start doing things like you're seeing some of the nice work from PerCon and others where you start annotating. When you start looking at a river, maybe I should start bringing up what the floodplains are and what date it is and previous images and reminder systems. And then the things like another one we like is Situ Map, where you can start dragging and dropping the UAV imagery and see what was before and after and measuring the distances on the fly without having to go through Esri. All of some of these tools are very sophisticated, but they're oriented for professional geographers in the GIS community. Person in the field, boots muddy, with a laptop, and maybe that mythical high-performance computing TravelPro. What can they do with no sleep while they're munching on a power bar and wishing they had hot coffee? What can they do? That's what we're looking at. All right, so let's wrap up here. So what do I think this means to the ACM community? I think that disasters pose wonderful, important computing challenges to the computer community. You've got computer systems organization, you've got networks, information systems, you saw security and privacy. Human-centered computing, really an important aspect of this, particularly. And we've looked at human-centered computing, but a lot has been so focused on the citizenry and that humanitarian relief type of things, not on that initial first few days when these experts and are having to deal with stuff. And computing methodologies, particularly AI and machine learning, again, very important. And we know this. 2012, the CCC did a big study and came up with fundamental research that still is what we need. The crisis report that you can get from the CCC, from their website. Big ones are, how do you deal with all of this asynchronous linguistic imagery, geospatial data? How do you do with it? And particularly when the strategic people want it on maps, everybody else doesn't want it so much on maps. How do you handle uncertainty? How do you handle the newness of it all? And that every disaster is different. The spatial and temporal visualization of the heterogeneous data, different scales, how to manipulate it. What am I looking at? Where did the UAVs fly? Where did people have their cell phone? Where is the State Highway Patrol have some pictures that they took while they were at this bridge? And I, over in ESF 1 on transportation, could use that. Trust in data and the provenance and the staleness. Okay, was that really from a State Highway Patrol person? And was it really taken today or was it taken 2 days ago? How do I know that? And then working individually on underspecified tasks or working with others with loosely shared goals. So I'm doing stuff on things I don't know about. Now I'm having to work with other agencies, other counties, other federal, different people. Supposedly we know the roles, but we've never worked. I have never worked with you before, and we know that's a challenge for us as people. Where can we as computer scientists help with that? And computer-supported work groups, things like that. And no matter what, disasters are hard, and it's not the same exactly as a smart city or big data or cyber-physical systems. It's really different. This socio-technical systems approach that really enables decision-making at extreme scales under extreme conditions is a specialty in and of itself for computing. And so I hope you'll look at it and treat it as such, because it's really, really important. Because each year, all over the world, 1 million people are killed on average each year. 2.5 million are displaced or disabled, so they never go home, and they never regain their health. 2.5. And it's almost $1 trillion in economic losses. The number of disasters each year is not increasing, but the impact is increasing as we become increasingly urbanized, which means we're both centralized, so we get wiped out by more of us are in one location get wiped out, and also because the lower economic, the poor people are more adversely affected by these types of events, living on the margin. So that concludes my talk, and I think Jan's going to step in and we're going to start looking at questions.
Wow, thanks so much, Robin. That was fantastic. And we've got quite a few questions, so hopefully we'll get through at least a few. You covered this to some extent, but lots of questions about what are the roles for machines and where do they fit in the response, restoration, or reconstruction?
Okay, run that by again. Sorry. Could you repeat the question? Sorry.
Sure. Yeah, the question was, where do machines fit in the process, more in the response, restoration, or reconstruction stages, or all of them?
I think that machines, if we're talking about things like unmanned systems, ground vehicles for building collapses, marine vehicles for checking the underwater portions of bridges and ports, and of course aerial vehicles, which are really a darling. They're cheap and expensive and becoming ubiquitous. They're actually useful for all phases, before and after the disaster. And think about it, makes kind of sense. If you're one of these people, well, when something bad happens, do you like to suddenly download a new app or learn a new skill on the fly? I think the official term is, oh, hell no. You use what you're comfortable with. So using these before disaster, having emergency managers, counties are beginning to use UAVs to map out what the land use is and whether the developers are really doing what they're saying they're doing and putting the mitigations and stuff like that. And then they have it available for when they get a flood situation. That's wonderful. And we're beginning to see some state departments of transportation beginning to look at remotely operated vehicles for underwater to do routine inspections of bridges. You know, in the United States, most of our bridges are hitting that 75-year mark old, and that means they really need some serious maintenance, and it's hard to get manual divers down there. It's very dangerous. But having that available now for when you've got a huge storm surge that's going to come through, wonderful to have that. So it's all through those. I did see a question about CCC, chaos and something. I'm sorry. It is an American organization called the Computing Consortium Community. And it's part of the Center for, the Computing Research Association in the United States. So if you look for that, you can see that that report there, the Crisis Computing Report. Sorry about that.
Thanks, Robin. Another question is, how uniform is the availability of services across the United States and U.S. territories?
You know, Puerto Rico as a U.S. territory is always a special case. And we had one of our CRASAR members was down there for 3 weeks in Puerto Rico, and he has lots of stories. And that gets back to that idea of urban stuff versus wide area stuff. So once you go into a wide area, so even think about Harvey hitting Houston. Downtown Houston is heavily urbanized. The suburbs are a mixture of urban built structures, but also have agriculture. You know, half the county is got huge ranches. It's a historically where you've had a lot of sugarcane grown, you've got a mixture, and that does make it harder. When you go out to rural areas, even I think of Washington State, I think of Seattle, between Seattle and Vancouver, 2 major metropolitan areas, you've got no cell coverage once you get out of those metro areas. And you've got these mountains that are blocking cell coverage and things, so it's very difficult. It's very up and down. So again, no one size fits all.
Thank you. And maybe kind of a 2-part question. How can machine vision and event prediction help in disaster avoidance? And are there any attempts or developments in using predictive analytics?
A lot of people in the earthquake engineering centers are doing a lot with predictive analytics. And I think that's one that we've seen a lot of good work in. To me, one of the more exciting ones is to do the post-disaster analytics. So one of the things that the civil engineers here at A&M have been looking at is, hey, look, why do we have to fly and map everything, every part of the disaster? can I just get, if I know this subdivision was built at the same time, all the houses were here in about a 10-year period according to this code, I only need to sample a couple of them to know to statistically estimate what the damage is. I can say whether this is going to, we need lots of work in this neighborhood's fine. And by the way, if I sample a couple of these neighborhoods on the west side of the county and they're all built at the same time, I can predict what their status is over on the east side. So that's very exciting. So it's a combination, it's not predictive so much as rapid reaction, quick calculations. None of this take 2 darn weeks to compute. We're talking about in 2 hours being able to take together. Some lovely work done by James Caberly had looked at, so with civil engineer John Mander had looked together at, can you trust data coming from social media? And so this was right after when the Japanese earthquake happened, and then traded at Sandy Hook, and the answer was actually the signal to noise ratio at the first 4 hours is pretty darn good. People start taking pictures of, holy cow, look at my roof, or look at the bridge down the street from me. And they take pictures of like that for about the first 4 hours. And if they're close in, you could really, if you can geographically tag where they've taken the picture, you know it's from that region. Bingo, great. The civils were like, no, that yes, it looks bad, but that's superficial. They have special names for the superficial distance. I don't recall. But then, 4-hour mark, that's when people start photoshopping in, scenes from Independence Day with the Statue of Liberty falling into the water and photoshopping sharks in, in the floodwaters and things. So you really can't trust it after that. But those are some of the things you can do.
Wow. Talking about cybersecurity, are you aware of any documented cases of cyber loitering during disasters? So, for instance, something like data theft, exploiting the disruption caused by emergencies?
I don't know any of it personally, so I would not rule it out. I do personally know it has always been a big fear. At 9/11, very big clamp down on information, trying to do. That was a terrorist event, the same thing at the Pentagon, trying to, that was a huge major thing. And would the terrorist exploit standard operating patterns of ESF9 and things like that? That was a huge deal. So that is something there. Even now, and with FirstNet, a lot of the meetings have been about how do we keep that exploitation from not happening. So cybersecurity is a big deal.
Thanks. Definitely on top of everyone's minds these days. You were talking about social media. So is there a role for social media in these disasters? Is there such a thing as a disaster relief mode for social media? And does it actually help the boots on the ground volunteers to coordinate a better response? You had mentioned that in the case of Houston, Waze wasn't of much help, for instance.
And I'm sorry, I didn't mean, like social media is bad, but I just wanted you to get some sympathy for the emergency managers on, there's no such thing as a free lunch. Anytime you get a tool that's going to help you, there's some consequence. And in this case is that. That said, Fort Bend County, having gone through 2 floods in social media, they got ahead of the curve. They had a UAV policy, and they were posting data. They started back on the 2016 flood. They started posting YouTube video of all the UAV stuff as long as it didn't have PII in it. And so what was happening is now people would call, one area was a senior assisted living thing, and people were calling and saying, oh, what's the flood? What about my elderly dad or my elderly mother? We live out of state. Should we come down? This is going to be one of the, like Katrina, where they're just going to leave them to die. And they could say that the people who are taking the call said, hey, go over to YouTube to this location, and you'll see the aerial video, and you can see the flooding's definitely not in that area. It's over, but it's not really there. And people loved it. And the same thing throughout, and the ability for the county judge to say, no, we really don't have, this is why we made this decision. You're seeing the same information we're seeing. That just really shut things down a lot. Now, social media, locally, when you're in there, we don't have good connectivity. What can we get on our cell phone? Sharing among each other is great. Really have to trust it, that issues of provenance, what information is it worth my battery power? How many Morphe packs am I going to be carrying today to get this? And so that's a different set of questions. So it really requires a lot of research and thinking. A lot of companies are looking at it. You know, lessons from the military. One of the groups we used to work with looked at that. It's GeoSuites, taking tactical operations software for sharing and social media among the tactical teams, military teams. Problem is those tend to be expensive, and anything that costs over about $10,000, $30,000 max is often too expensive. It has to go to a special grant. Or anything that requires lots of interconnectivity, you realize, since hopefully from this talk, that they're not interconnected. These different, why is this different municipality or this different department within this municipality going to have the same thing as this other group? You know, and how, so now you have to have huge change or everybody agree to a different infrastructure, which will be nice to have something like an LTE, which every cell phone, everybody can figure that one out.
Thanks, Robin. Another question we have is, how much does military technology apply to disaster decision making? Is there sharing of this type of technology outside of the military with other governments or NGOs?
The military in the United States, NORTHCOM, is responsible for bringing in military assets. And military assets in the form of the National Guards have always been used by governors, right? Because that's part of the job of a state's National Guard. So they use their technology. So here's an example of how a National Guard brings to the table. When Hurricane Rita came through, Leo Lechat, who was the #2 person, Craig Fugate was still head of Florida, the State Office of Emergency Management, called and said, Robin, you guys have got some of those new UAVs you were showing us and used at there. Can you fly down in the Keys? And I looked at the distance and I said, you know, Leo, the National Guard just got some Predators to train on. That's a much better use, higher altitude, much distance, way better sensors than anything we've got. And they were like, oh, right, and they're on our list. You know, we can call them up at a moment's notice. He said, gotta go. You know, and Wynn called them and they flew and got the information. They started flying the Predator, and both Texas and Florida does this routinely. You get a hurricane coming in, you have the National Guard run Predators to get the 2 days before pictures, and then as soon as the weather clears, you run them to get the after pictures, the before and after, and have them. So those are places where technology, same thing, the National Guard brings in all of the, they bring in a lot of communications equipment, which often, not always is interoperable. That continues to be a surprise. And again, the FirstNet people are working on that, to improve communications. And NORTHCOM is trying to support this every way they can. So they're trying. Is there a lot of international cooperation on this? I don't know about military sharing technology. The United States, one of their missions is to do humanitarian work because we want to keep everybody safe and happy. And if you're displaced and out of control and there, then the economic consequences, unrest, leads to problems. So who knows? I don't have a good answer on that one.
Thanks. I'm not sure if you have the answer to this one, but how can organizations or businesses get financial support in developing robotics for search and rescue?
Not to be negative, it's sort of like a good luck with that. The problem with emergency response is it's unlike military funding. So if you're trying to do a business model for the military, they have centralized purchasing, and it's kind of one size fits all. They decide which robots they're going to use with that, and they do big grants. You know, they're going to do $5 to $10 million at one shot. Emergency response, the federal government actually has not approved unmanned aerial systems or ground robots for that, for the cash, because they said, well, we don't have standards for them. Until we have standards, we can't do them on the federal government list. And then most states, one exception is New Jersey, they were an early adopter of robots because New Jersey, for whatever reason, did not do ditto. Whatever the federal government's requirements for purchase list, things go on a purchase list, we'll just duplicate, which most states do. They said, no, we'll make up our own purchase list. And so they were actually able to start buying robots. And now they're beginning to allow through special UASI grants buy robots and stuff, but it's not there. So you've got a very distributed, decentralized purchasing. You've got those 15 different 16, sometimes the states add new emergency support functions, 15 to 17 emergency support functions, each looking for something different. And they're all looking at, if it's got to be under $30,000, even better if it's under $10,000, because otherwise they have to go to their county, it has to go for bids, these processes, and they have to get a state grant or a federal grant to buy it, and it just goes downhill. And it's a low volume, low profit margin market on top of it. So it's really been a problem. I used to be a co-director of an industry university cooperative research center trying to address this, and it's a tough nut to crack. I don't want you to not start to try, but just be aware there's no quick and easy way to get into this market. Anything associated with emergency management is a hard nut to crack because of the economics.
Wow, so major challenges there. Going back to the issue of bandwidth and networks a bit, with a 10 times improvement in wireless throughput, will 5G have a major impact on emergency response?
I think it's a wonderful step in the right direction, but only if it's coupled with prioritization of the right information. The point is to get the right information, the right person at the right time. Right now, most emergency management offices try to shove everything out to everybody and hope they'll figure out what's valuable to them because they can't really anticipate. And people boots on the ground don't even know what's available to ask for a lot of times. So that push-pull is very important. But until we, and I think this is a big thing for knowledge representations, ontologies, human-centered computing, what do people need? What do different decision makers, stakeholders need? And what is the best format? Sometimes they don't need an image. It's just simply a bar graph, red, yellow, green type of indicators. What's the best visualization? So having better throughput won't hurt, probably not, but that data avalanche and the cognitive overload of getting too much information is a huge problem. So we need to couple that.
Thanks. Question about security also. Is the government adopting a secured cloud-based depository?
No idea.
And another question from earlier on, can you use unmanned aerial vehicles as couriers for SD cards and thumb drives?
The average distance we were seeing was around, or the distances we were seeing just at Hurricane Harvey, Fort Bend County, one of the wealthiest counties in Texas, and a suburb, the western suburbs of Houston, right? So that should be a good one to go through. If we did just straight as the crow flies, we're talking 20 miles. So we're not using UAVs for that. They had long ago, Fort Bend said to cover this, and we're just going to do a courier system. So no, I don't see that as a viable one. Oh, and by the way, probably don't even want to get me started about the airspace in a disaster. It's very crowded with like medical helicopters zooming by, low altitude hoisting operations, pulling people off of that. So the air traffic is very difficult. You don't want to put more things in the sky if you don't wind up doing it, if you can do it on the ground or do it through a communication or going to a landline or something.
Thanks, Robin. And maybe one more question before we sign off today. Are relief institutions or officials receptive of informaticians, I think meaning computer scientists and informatics professionals?
I think they're like everybody else. So let's go back to that analogy that I try to make with universities and academia. You know how we hate for people to come in and tell us that they've got all the answers to academia's problems, right? That we're not teaching right and we're not doing it right and we're not there. And of course we bristle at that. I'm assuming us being professors, right? I've seen, and I'm sure I've done it too, with that. We've got a solution to your problem. If you go in and try to say, what are your problems? What can you do? What can we learn from you? What can we help? And go from it from that standpoint. They have been wildly receptive, but they get real bristly, as you can well maintain. And on top of it, you know, you're thinking all of this response work is not hugely well paid, right? I mean, we as computer scientists, we've got lots of money. I mean, we have a very good income, and now we're coming in and telling this person who's working a thankless job, being prepared for an eventuality that may never happen, and we're so smart. You're doing it all wrong. Computers will help. Well, you know, they probably thought about some of these computers and some of the applications they would like to see, and so we really need to be sure that we approach them with respect. And every time they have been very receptive to it. Now, whether they had the money to buy some of the solutions, not so much. But I think they're certainly willing to it, and I think that's something that we as a community can reach out to more.
Well, thanks so much, Robin. Again, I'd like to thank Robin for the fantastic presentation and the insightful answers to the many questions, and I'm glad we were able to get through quite a few of them today. A special thanks to each of you for taking the time to attend and participate today. This webinar was recorded and will be available online in a few days at webinar.acm.org. You can find announcements on upcoming webinars and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, and you're going to see that on your screen in about a second. On behalf of the ACM, Robin Murphy, and myself, Jan Tumanowski, thanks again for joining us, and I hope you will join us again in the future. This concludes today's presentation.